Hello, my name is Anthony Fajardo, and we are Team Garados. Our goal of our project was to develop a wireless sprinkler head attachment that would toggle on and off based on soil temperature and humidity. My side of the project was involved over here. I worked on the humidity sensor and the temperature sensor. Now what this is doing, we have one of these prongs putting current into the soil, while the other one is reading the soil resistance. If the soil is wet, that means it's going to be more conductive, so our resistance is going to be low when being read by our board. If the soil is dry, that means we are going to have more resistance, so that means it'll be time to turn on the sprinkler head because the soil is dry. This is all based on temperature, because if our temperature sensor reads that our soil is very hot, that means it's going to give a false reading out from the humidity sensor. So if we go past 80 degrees on this soil, we are not going to turn on the sprinkler head.
My name is Christian Rodriguez, and I primarily focused on this area right over here. This is the interface that we used to connect to the NRF 51422. Each button is specified on different areas of the project. The top button, when pressed, is meant to set a 30-second timer and turn on the actuator for that amount of time. Obviously, it's only for testing purposes, so we could change the timer to be for 10 minutes or 15 minutes, depending on the desired time by the user. The right button is meant to turn off the system, and the left button is actually to turn on the system. The bottom button is actually the soil button. What that means is it uses the humidity sensor and temperature sensor to see if whether the soil is ready or not. I primarily focused on programming the board to connect everything together, as well as the possibility of using a mesh network, which actually didn't work. But what I do have working right now is the phone properly connecting to the board, and also reading the signals from the humidity sensor and from the temperature sensor, which is in the soil right now, to give us the proper reading to turn on the water.
It's Peter, and I was in charge of the power management for the sprinkler system. Originally, we intended to use the supercapacitors for the microhydro generator to charge up and power the board. But we discovered that the supercapacitors dissipated within minutes due to the high resistance of the board. So for an alternative, we just decided to use a 9-volt battery as the main source with the microhydro generator as the secondary source. We discovered that the microhydro generator outputted alternate current because of the unstable water flow. But we need direct current in order to power the board safely. In order to fix this issue, what we did was pass the microhydro generator through our rectifier to convert the alternating current into direct current to power the board, and it doubles up as a protection so that the power does not backfeed. Now we take the direct current and pass it through the voltage regulator right here to create a stable 5 volts to power the board safely, because normally the microhydro generator will send through 17.5 volts to 21.5 volts roughly, which is way too much power for the board.
Hi, my name is David Lee, and for this project, I'm in charge of the casing for our sprinkler head. Here's the casing in 3 parts. I designed this way because of the limitation of a 3D printer, but here's the base, and here's the middle section, and here's the top. This is universal because you could easily just take a sprinkler head like this and put it through the top and screw it in or unscrew it and change out a different head should you wish. Another part that I'm in charge of for this project is also how to control the water solenoid valve, which I did by using this transistor right here. This transistor is connected to this Nordic board, and the Nordic board will send the transistor a signal to turn the transistor on, which would then allow the power from this 9-volt battery to go to the solenoid. And another part that I'm in charge of for this project is the switching of 2 different power sources to the board. I solved that by using by adding a diode to each of the power source, so that it doesn't the two power sources doesn't feed back into each other, and by default, like whichever power source has higher power, that will be what's been going to be used to power the board.